Hello and welcome to a new episode of the Computomics podcast. Our guest today is an entrepreneur and the co-founder and CEO of Plant-Ditech from Israel, Keren Moshelion. Welcome.
Thank you. Thank you for the opportunity to talk. Thanks a lot.
Oh, we're so happy to have you. And I know you know that we always like to start out of left field with an icebreaker. And I was wondering, what's a source of inspiration for you?
I think there are many different, leaders, political leaders, like Churchill or Ben-Gurion, in my case. I'm from Israel. And also some women entrepreneurs from different fields that I find interesting, either from legal area or from many different areas. As a woman, of course, I get inspired from such women. So
you are currently, of course, a leader yourself. You are the CEO of Plant-Ditech. For those of our listeners who don't know Plant-Ditech, what is it? What is the company about?
The company is in the field of plant phenotyping. We are a company which is a spin-off from a university, the Hebrew University. And it's a product that is aimed for help accelerate research and deepen the research. What we do, the platform that is a spin-off and we continue to develop and commercial it, is a plant soil atmosphere continuum phenotyping platform. This means that what we do, we can control the soil and water and measure the plant and the atmosphere conditions, including soil and water, and measure many plants at the same time in order to understand which of the plants, it could be different varieties, which of the plant variety is much stronger in different conditions. So it's kind of like a psychometric test for plants. To understand very fast, like a preliminary test to understand which of the plants are stronger in different conditions, which are more productive, they provide more yield. So you can look at it as a psychometric test for plants.
So what type of environmental conditions can you simulate with this system?
So everything related to the soil water. So we can simulate different water supply during the day. It can change over the day. So each plant can get its own supply of water. It could be different, and also throughout the day it could be different for each of the plants.
Oh, interesting. So could you basically do a simultaneous A/B test?
Yeah, so this is what we do. And we also can control different nutrients and different nutrient levels. Also, so you could provide 2, 3, 4 and more, 8, 10, whatever number of different nutrient levels. You can provide different nutrients also. So as a researcher, you have the full freedom to decide which treatment you want to provide to the plants and which soil water conditions they shall have. And again, different plants could get different cocktails, different salinity levels, different microbiomes, whatever you decide as a researcher that you want to implement into the solution.
So basically, if I understand you correctly, the different stresses and conditions you can test, I guess, would be irrigation, drought, salinity, nutrient level, maybe?
Yes.
Is there something I'm missing?
Well, these are the main, also microbiome, biostimulants, this kind of... So again, whenever it's as a researcher, you decide what you want to put in. We control the irrigation fertigation, and it could be very different from researcher to researcher what he implements.
Interesting.
And also, by the way, from experiment to experiment, you can do one experiment, let's say, with salinity levels and in combination with other nutrients, for example. So different levels of this different levels of that. And another one, which is drought specific or drought including salinity. So you can do different experiments with the same platform that change the condition from one to the other, and also throughout the experiment. So a lot of flexibility on that.
Yeah, that sounds almost almost impossible. Can you take us maybe into the lab or into your setup? What does it look like? How big is it? How can we imagine this platform looking like?
Yeah, so you can build it in any number, okay? It could be from a few to 100, it could be also 500, it could be 1,000. It all depends on the customer need. It depends on its budget, on the space that he has in his greenhouse, because this is a system that goes into a greenhouse and or growth chamber. And it could fit into any type of, size that the customer has. And again, the budget constraints. One unit basically is like an independent unit, so you can just add to it more. But it's a system. It's a system with software, with hardware, with all the irrigation components and so forth. So it's a whole system, but each and every unit is independent. So you can have as many units that you like.
And so you already mentioned a few aspects that it consists of software and hardware. I think it would be really wonderful to understand even more how it works. It's greenhouse, growth chamber, and then how is it set up?
We provide everything which is around the system to automatically manage the irrigation and also the reading of different sensors, because the system is based on different sensors. These are physical sensors. One of the major sensor is a scale, mini scale, a lysimeter it's called. And this mini scale helps us to understand the different water balance, either in the soil or used by the plant. I can explain more about it, of course, but just to give you an idea. So we, again, provide everything around the system, and we connect to the irrigation fertigation of the customer to his system of irrigation fertigation at the greenhouse. But all the rest we provide, including the software to operate it, including the software to analyze it. So the whole solution we provide.
Let's go into that example. You said you can give a concrete example. I think that would help in addition to increase understanding.
Maybe I'll talk a little bit more about what we measure, because this will help to understand why we're using these sensors. So we measure the dynamic changes of the plant during the day and also between days. We are measuring the plant response in terms of its physiological status. So what we measure is very hard to measure, let's say, manual physiological traits. We measure automatically, very precisely on the system. And a lot of them relate to water balance, because water activity actually tells us what is the productivity of the plant. Because every time the plant lose water, it also doing CO2 fixation. So it helps him to produce more, so and to grow. So what we're doing is we are measuring this physiological activity, which is correlating highly to yield. This is why we can do very short tests. This is how we do very quick tests, which are days or weeks only, not full seasons, because you can understand very quickly, because we measure it in such high density, 500 times a day. This is how much we should measure the plant. You can immediately see the trends, and also with statistics, you can see the differences between the lines, the varieties. And this is with the help of these physiological traits that are immediately, the plant is responding and you capture it because of this dynamic view of the plants. So what we measure mainly is the water activity by the plant. So the water activity, the growth of the plant, the biomass gain of the plant, and also conductance or stomata activity, and water use efficiency, root water uptake. So everything from the root through the shoot to the atmosphere in terms of the water balance. And this gives us a lot of information, the researcher, of course, a lot of information about the plant productivity and the growth pattern, which eventually will provide more yield. And this is why we're using this mini scale, because this mini scale helps us to understand what is the water balance with the plants and its growth, its physiological growth. So this is one sensor, which is a major sensor. And then we're also using atmospheric sensing. and also additional sensors that you can add to the soil, to the plant. So we have also a variety of sensors you can add on top, which are either plant or environmental.
So maybe going into the customer journey now, if we wanted to use this, do we go say, hey, Keren, this sounds amazing, this product. Do we just have a base system and then we can add, okay, for us, this sensor, this optional sensor would also be helpful. And you add that basically when you order, or is it something that's integrated and can then be changed later?
So both. You can either order it from the start if you're interested in a certain sensor. So yes, we have a basic setup, which includes the mini scale and the atmospheric sensing. And then on top of that, if you want to have more sensors, either you buy it from the start if you have the money, or you can buy them later and add them later. The system is very versatile and it allows you to add or either units to the system or sensors. And also we extend the sensors list all the time, so you can find more sensors there.
What was the last sensor you added? If you can recall.
NDVI and IR sensors for the canopy, whole plant canopy temperature, leaf temperature. So we're adding all the time more capabilities.
Wonderful. Thank you for going into more detail on that. So you mentioned budget a couple of times. If you're willing, what's this base setup? What's the rough kind of ballpark figure for the base setup?
So a base setup could start from around $40,000-$50,000 US and or euros, roughly around that. And it all depends on how many units you want to have. As much as you increase the number of units, the price per unit will go down, as it's a system, and you invest in the software, you invest in all the system as communication and irrigation and so on. So this is the idea. For example, a handheld physiological measuring transpiration, like we measure, if you buy a handheld, which has less capabilities, it doesn't irrigate, it's not measuring all day, it's not measuring all the plants at once, it's measuring only one by one on a leaf level, and we are measuring the whole canopy. So if you buy one of these, you can already buy about 12 units of ours. So you already buy 12 whole plant measurement tool, which is much, much more productive. And you can, of course, as you have more budget, you can add more.
Yeah, that makes sense. You mentioned it a couple of times, but I don't think we've really focused on the software side yet. If you're measuring 500 times a day with X amount of plants, maybe simultaneously, that's a huge amount of data. Take us on a journey into the software. How are you processing this, and what kind of output can researchers or breeders maybe take from the system?
Yes. So first of all, our measurements are immediately quantified. It's not like, let's say, an imaging tool that you just take the image and then you need to analyze it. You create a cloud point and then you need to analyze the cloud point. It's a lot of data, very heavy. Not in our case. In our case, it's a direct measurement by the lysimeter, by this mini scale, with the other sensors. So the amount of data, although it sounds big, it is big, 500 times a day, but it's immediately a number. So it's easy just to lock it down and have it stored. And the way we do it, we have two software actually. One is in the greenhouse to manage the experiment on a local computer. It also helps to gather all the information from the different sensors, and then it uploads it into cloud software, which is managed for us by Amazon. And so it's, quite a common tool, and we manage it for the customer. So the customer doesn't have to hold any servers and deal with this computing, very heavy computing. We just do this work for him.
So how do you provide the data, and how much can maybe researchers or your customers have an input on how you provide the data?
So they have a nice interface, that very nice GUI that they can just play with whatever the time frame they want to look at, whatever they. We also perform statistical analysis in the software, so they can already choose their statistical test that they want to look at, the data. Either they want to look at the raw data, so they decide. They just choose the parameters, they choose the length of time, they choose, how they want to see the data, and they get a graphical view, they get a table with the data, whatever they want, they can download it. They can also upload data to the software. For example, let's say they have a certain manual device they're also measuring with, they want to upload data or imaging data. So they can, any quantified data, they can upload with a timestamp to the software. So it's open from both sides, either upload or download. And it can also be done automatically with the API. So it's very easy. You can either do it manual with CSV file or with the API, just a push of a button and you have it.
That's quite the range, especially like if you go from this like ultimately processed data to also the raw data, which you mentioned. I think that might be for many in our audience who are maybe on the research side, that might be especially interesting to have access to both.
Exactly. And also don't forget that this system was developed in a university initially. So, we capture all the needs from the start of a researcher. It's really designed for experiments. It was built around that. And especially in drought or abiotic stress type of tests, but not only, also in biotic stress. We can, because it's physiological data that we are capturing, the plant is showing us when it's feeling the stress very fast by the data. You can see a reduction in transpiration activity, slowdown in biomass growth, and you can capture it when it happens. And in real time, and in the software, you can really see it in real time also, the data, while the experiment is still running. So it's really neat. You don't have to wait until the end, clean the data and all that. So it's really helpful.
It sounds almost like a magic potion or like a speed bump in a computer game for the classical processes, both in, like in research, testing, experimenting, but also when it comes to commercial application. Maybe as we kind of, look into that end of the value chain, do you have any insight into how much you can accelerate agtech R&D in that area?
Yeah, definitely. We have customers from all over, let's say, the research space, either from universities or from breeding companies or from biochemical. So kind of all the range of different aspects of research. This is a platform that can be used to whatever the research question is in abiotic or biotic stress. So, and what we learned from our customers, especially the commercial ones that are really looking into that, because every dollar spent, they want to see a return. They are saying to us that it saves them at least I'm saying, because it could be more, 1 year or 2 years of research, of doing research, but eventually it's much more because they can eliminate a lot of the trial and error that they do in the research cycle. So if a research cycle, let's say, take for a commercial company between 4 to 7 years, even sometimes more, you can cut a lot of this trial and error that you do in the field later on. And this, it's harder to quantify, but I'm sure this is 2-3 years, in the overall, at least on top of this, what I described before. So it's very significant, either in the, let's say, straightforward time saving, or in the, so it's, let's say, 2 years, and then you can add up all this trial and error that is being done, all this waste that is being done in the field, that you can save a lot of it already in the pre-screening in the greenhouse.
So the plant array system that you've given us this great insight to now, who has been using it? Can you maybe name a few customers that you've worked with on that?
Sure. So we're lucky to have in our install base very prestigious customers, distinguished ones like Wageningen University and UC Davis, and also the Danforth Center. And we have many facilities that, customers that use our system around the globe, from different states in North America, different countries in Europe, to even Asia. like Tokyo University, and also others in China, in India, and also commercial companies like Mars Wrigley, Profarm, C6, so different, ICL, Haifa Chemicals, a lot also in that space.
Wonderful, Keren. So I wish we could talk a little longer because this was very interesting. But I'm sure there will be connections made between our audience and you after this podcast. We will put your contact information in the show notes. So our listeners out there, feel free to check out Plant-Ditech and get in touch with Keren if you want to learn more. Thank you, Keren.
Thank you very much for this opportunity. Thank you.
Thank you for listening in today. Want to learn more? Then check out our show notes and more info on computomics.com. If you have questions or want to propose a next guest, please reach out to us at podcast@computomics.com.